So welcome to this tutorial where we'll be looking at P191 to Fit 10 on projectile motion. Question 1 reads, a stunt motorcyclist attempts to jump a river which is 5.1 meters wide. The bank from which he will take off is 2 meters higher than the bank on which he will land, as shown below. Calculate the minimum horizontal speed he must achieve before takeoff to avoid landing in the river. Calculate the minimum horizontal speed he must achieve before takeoff to avoid landing in the river. Okay, so this is a simple question on projectile motion, where we have this stunt motorcyclist attempting to jump a river, and they're telling us to say he's attempting to jump a horizontal range of 5.1 meters, and the bank at which he's starting from to a bank at which he's landing, there's a vertical distance of 2.0 meters. So they want us to calculate the minimum speed he must achieve before takeoff to avoid landing in the river. So what are we going to do? So here we are going to apply this formula. We'll say range is equal to initial velocity in the x multiplied by time, because initial velocity doesn't change in the x-axis. So we're going to say range is equal to velocity multiplied by time. That is the formula for calculating range. But if we look at this formula, there is time involved here, which means we are supposed to calculate time first. And how are we going to calculate time? We are going to use motion in the vertical axis. So in the vertical axis, we have displacement height, which is equal to 2.0 meters. We have the acceleration due to gravity, which is going to be equal to what? Which is equal to 9.81 meters per second squared. What else do we have? We have initial velocity. Since when jumping, he's going to start his motion initially. Just at the point of starting, the motion will only be in the horizontal axis. So we're going to have this type of projectile or trajectory. It starts in the y-axis only, on the x-axis only, then starts descending after gravity acts on him till he reaches that point. I'm trying to come up with a perfect trajectory. Start from there. Okay, yes, just like that. Okay, so this is the trajectory it's going to follow. So at this point of takeoff, the velocity in the y-axis is going to be equal to 0 meters per second. Why? It's because the motion is initially only in the x-axis. So we're going to use motion in the y-axis to calculate the time of flight, and we'll plug that time into this formula to calculate the range. So in the y-axis, we're going to say displacement in the y will be equal to initial velocity multiplied by time plus half at squared, like this. So since initial velocity is equal to 0, it's taking out this part of the equation. So we're going to have 2 meters being equal to half 9.81 t squared, like this. So I have 2 being equal to 4.905 t squared, like this. So if you notice, our gravity is going to be equal, or is going to be positive, because in this case he's traveling along the direction of gravity. So the g is going to be positive. So in case there were those who are not sure about the sign of g, here it's positive since it's moving in the direction of gravity. So I'll say over 4.905, even this side over 4.905. Okay, our t squared will be equal to 0.4077. I take a square root on both sides of my equation. Let's find my time of flight as equal to 0.6386 seconds. So this is the time of flight using motion in the y-axis. Then we're going to get this time that we've calculated and plug it here to calculate the initial velocity, given that we already know the range that this motorcyclist is supposed to cover. So I'll go back to my red pen here. So I'll write it here on this side. Our R is equal to Vxt, which means I'm dividing both sides by t, even this side by t. That means my initial velocity in the x will be equal to 5.1 over 0.6386. Therefore, my initial velocity in the x should be equal to, let me just punch this in, 7.99 meters per second. That means my initial velocity in the x should be equal to 7.99 seconds. So if this guy doesn't want to land in the river, he should start off with the initial velocity in the x, which is equal to 7.99 meters per second. And just like that, it means we are done with question one, or the first part of this particular question. So what else are we going to do? Let's move on to question two. And question two reads, a ball is projected horizontally from a cliff with a velocity of 15 meters per second. If it takes 3.6 seconds to reach the ground, then calculate or find one, horizontal velocity of the ball just before it hits the ground, two, vertical velocity of the ball just before it hits the ground, three, height of the cliff above the ground, and four, the maximum displacement of the ball. The maximum displacement of the ball. So they've said the initial motion is in the horizontal axis because they've said a ball is projected horizontally. So if I want to draw my free body diagram, I'm going to say I have a cliff there, and that's the level ground. The ball is projected horizontally. Let me draw the trajectory of the ball. Okay, so I'm starting from that point, going in that particular direction, and they've given us to say v initial in the x is equal to 15 meters per second, and they said it takes 3.6 seconds to reach the ground. 3.6 seconds to reach the ground. So the time of flight is 3.6 seconds. Now, question one, they're asking to say calculate the horizontal velocity of the ball just before it hits the ground. So for part one, I'm sure by now we're supposed to know that the velocity in the x-axis does not change because there is no any other force of acceleration that acts in the horizontal axis. So the same velocity you have at the initial point is the same velocity that you're going to have at the final point. So which means the final velocity in the horizontal axis is still going to be equal to 15 meters per second. The vertical velocity of the ball just before it hits the ground, which means we are trying to calculate final velocity in the x, so or in the y rather. So what we're going to notice, they've told us to say initial motion is just in the x-axis, which means v initial in the y is equal to what? Is equal to 0 meters per second. We are looking for v final in the y. We know to say there is gravity here, which is positive since we're going down 9.8 meters per second. Then what else? We already have the time of flight. So what are we going to say? We're going to say v final will be equal to v initial plus at. V initial plus at. This is the formula we're going to use. We're looking for v final. What is our v initial? Our v initial is 0 plus acceleration is 9.8, or we can use 9.81. 9.81 multiplied by the time of flight, which is 3.6 seconds. And thus, ladies and gentlemen, our v final in the y will be equal to what? It will be equal to 35.316 meters per second. 35.316 meters per second. That is our final velocity in the y-axis. Question 3 is saying we should calculate the height of the cliff above the ground. Calculate the height of the cliff above the ground, which means we're looking for the vertical displacement there. So we're using motion in the y-axis as usual. This is part 3. Part 3, we're going to say displacement, here specifically in the y, will be equal to ut plus half at squared. We have initial velocity as 0, so which means our displacement in the y will be equal to half at squared. This is going to be equal to half multiplied by acceleration. We're going down, so acceleration is positive, multiplied by 3.6 squared, like this. Okay, so that means our displacement in the y, or height of the cliff, is going to be equal to 63.5988. 63.5988 meters. That is the height of the cliff, 63.5988 meters above the ground. That's the height of the cliff. Then the last part of the question is saying we should calculate the maximum displacement of the ball. The maximum displacement of the ball. So here you're going to notice to say we have we've calculated the vertical displacement. And what else? Did they give us the the horizontal displacement? Because if they say we should calculate the maximum displacement, we're basically going to get the vector of displacement, which means we're not going to follow the direction, or we're not going to follow the path, but just the overall trajectory of the ball, which means I'm starting from that point, going straight to the point this ball is landing. So that is the maximum trajectory. And in order for us to find the maximum trajectory, we're supposed to use the formula for calculating the magnitude of a vector, which means I'm going to use the maximum, or I can say maximum displacement will be equal to the square root of x squared plus y squared, of which x is the horizontal displacement, whilst y is the vertical displacement. So since we haven't been given the the horizontal displacement, we've calculated the vertical displacement. Let's start by calculating the horizontal displacement first, then plug it into this particular formula. So I'm going to say uh, our range will be equal to v multiplied by t. This is going to be equal to what? Velocity in the x is 15 multiplied by time, which is 3.6. That means our range is equal to 54 meters. 54 meters as our range, and we're going to get our maximum displacement to be equal to 54 squared plus 63.5988 squared. Okay, I'll plug this the way it is in my calculator. I'm going to get a final displacement of 83.431 meters. So that is the maximum displacement of this particular ball, which is projected from the top of the cliff, which is 54, or rather 63.5988 meters high above the ground. And that, ladies and gentlemen, is all about question 2. So thank you very much for watching this particular video. Remember, for the full solutions in this particular tutorial sheet, register with us. All the solutions are already on our drive waiting for you on our website. Just follow the procedure that I've included in this on the description of the video or the description of my YouTube channel, and register with us in P192 and all other pre-med courses and excel in your academics. Until next time, ladies and gentlemen, remember to subscribe and stay blessed.